Hey, what's up, guys? All right. Sorry about last class. Had an emergency, so we'll be circling back to the topics at hand. I think we're going over methods, return statements, and method parameters today. So getting a little bit deeper in classes. So you'll be able to see how to basically add new functionality to our little vehicle object, as well as get data out and get data in, which are arguably the most important parts of using an object. So let's just dive right in. All right. Cool. Again, I have the chat window open in the video, so if you're viewing live and you have any issues, please do let me know. If everything is fine, also please do let me know. It would be nice to get a little validation there. All right, so here we go. So let's talk about methods first, okay? So the first thing I'm going to do is come over here to the blackboard, right? God, I should make a macro for this. This is getting really annoying. Okay, whatever. All right, so methods. All right, so what does a method look like on a class, okay? Right, so what we have here is we have the return type, okay? And then we have the method name, okay? Then we have obviously our open parenthesis. You've seen that notation before. And then you're going to have a parameter list, which is going to be a list of 0 to n number of parameters. So you can have any number of parameters. I will say that while in present-day computing, it's okay to have as many parameters as you want, literally. Back in the old days, when you're dealing with embedded systems, in fact, that's actually true today still, when you're dealing with embedded systems that talk directly to a chip on a microchip on a circuit board, and you're using those kinds of systems where they're very constrained and you can't do a lot, those actually have a capacity as to the number of parameters you can pass into a method before it will just choke. The Nintendo DS was very much like that back in the day. You can keep going back and look at a lot of these, get these little LCD games they sell on Amazon. Those are like clones of what they used to have in the 80s. It's the same thing, right? Those things can only have so many parameters, and that's because the architecture of the CPU itself is so constrained that there's only so much that you can do with those particular chips, whereas on your computer there's just tons and tons of little tiny registers that you could fit data in. So you can consider this to be almost an infinite playground. Not really, but pretty close for our purposes. Okay, anyway, that was a side tangent. Hope you learned something. Anyway, inside the function is a body of the method, right? So that's pretty much it, right? Okay, cool. So one thing to note here is if the method doesn't return a particular value, then return void. Void means nothing. Literally the void, right? Okay, so that shouldn't be too hard to remember. And you've seen that a few times already, so just get used to that because it happens all the time. Cool. So, let's see. I'm going to go into this over here, because we're going to take this and we're going to steal it. We're going to go back to class 10. We're going to go to this add method to vehicle example. We're just going to copy paste that in there, okay? Because we're going to go ahead and use the same thing, okay? Now, we're going to do a lot of copy and pasting now, because we have a lot of reuse for these things. In the future, I'm going to show you how to create the vehicle class in a file once, and use it wherever you want without having to worry. And that'll be really sweet because it'll save you a lot of time and me time as well. All right, cool. So we're going to go ahead and go to our blackboard and do the same thing here. I'm going to grab this comment, which is our blueprint for a method. Okay, I'm going to paste that there. We're going to follow that, right? So I want to make, let's see, where was it? We had a vehicle demo over here. And we computed, okay, basically we had this. So I'm going to comment this out in a block right here, okay, so got that. So I'm going to write my method here, and then I'm going to clean up all those comments and stuff. So those comments are just not looked at by the compiler. I'm using them for notation or notes purposes right now, and we're going to delete those. But I'm going to build my method while using these as a reference. So the first thing is I want to return a type. But what do I want to do here? I want to display the range of the vehicle. I don't want to return the range, right? Because I want the vehicle to do all the work for me. I don't want to have to get the value and then do the printing statement. I want to literally let this thing do the whole thing. Okay? So I'm not going to return anything. So I'm already going to go with void. I already said that I want the range, so I'm going to name it range. Okay? Now, I don't need any parameters because the fuel capacity and the miles per gallon is already inside the vehicle itself. So I don't need any parameters, so that stays empty. And then we make our body. Okay? Cool. So how do we do this? Okay, well let's look at this. I want to system out print line the passengers and the range. Okay, so let's go ahead and take this. All right, let's copy paste that. And this is not a minivan, right? What we're going to do here is we're going to delete this, and we're going to say, and I'm going to be explicit right now. I don't have to be, but I'm going to, actually, I just want the range, right? So vehicle has a range of range. Okay, what is our range? Fuel capacity in miles per gallon. Okay, cool. So I'm going to delete this. Now, what's the best way to do this? Well, I could theoretically just do this. Okay, fuel cap times LPG. And I don't have to put that in parentheses, right? Because order of operations dictates that the multiplication will happen before the addition to the string. Right? But I'm an advocate for doing this. Okay? It's more clear what you want to happen first. I'm also an advocate of this particular notation, and check this out. I'm going to delete this, and I'm going to do this. Check that out. Now I can just choose it that way. Now, why am I using this? Well, two reasons. And not everybody would agree with me in this because it looks like more code. And that's fine. Everybody's allowed to have their opinion. The reason why I would go with this is because, number one, in the editor you get a nice little color coding that tells you that you're using the keyword this. The second reason is because you explicitly know automatically, because of what this means, that this fuel capacity is referring to this instance of the vehicle. So you're saying, I want the value of this vehicle, this vehicle's fuel capacity, right? So you are explicitly saying that, and this is generally good for other programmers that come across this. Again, not everybody agrees with that. They seem to like the whole less code is more, and it's like this whole being clever situation, right? And in my opinion, that there's a sense of entitlement there, because they're not really thinking about who the person is that's going to be reading the code. Depends on how much experience they have. If they have a year of experience, they may not catch the fact that this is, the value associated with the current vehicle, and they might be looking around the code saying, okay, well, where does that come from, right? If you use this, nobody is going to know, or nobody's going to question that because they're going to see it, right? So you're covering all your bases for just a little bit more of your code syntax, okay? So it's better to be more concise and explicit sometimes than to try to be some like clever asshole that's going to go ahead and write things in a ridiculous way. Like, you could make this FC. You could just make it FC. You could remove this comment, and everybody's like, what the hell's that, right? Well, the guy that's clever is going to be like, well, you can't figure it out. Like, that's kind of the mentality that you run to with developers sometimes, and it really is dumb. And just something to keep in mind, that nobody likes an ego, and nobody likes arrogancy. All right, cool. So we've got our range, and we've got our printout. So let's, I think that's pretty much everything that we wanted to do there. But we need to actually use this, right? Because we're not actually doing anything with it. Okay, so let's do something with this. So we're gonna make a vehicle. right? So we're going to make our minivan. Okay, so it's going to be a new vehicle. Okay, and then we're going to make a second vehicle because I want to go ahead and show that they both have their own values. So, okay, cool. So there's the second vehicle. And we're going to go ahead and do let's see here. I don't think we need that yet. I'm going to hold off on that. So I'm going to assign values to fields in minivan, and then I'm going to assign values to fields in sports car. All right, so minivan, let's say passengers 7. And we're going to say fuel capacity 16 and miles per gallon 21. All right, so sports car passengers is 2. Sports car fuel capacity is 14, and sports car miles per gallon equals 12. All right, sweet. So just for sanity, we're going to print out minivan can carry awesome. Okay. Then we're going to go ahead and do minivan dot range. Okay. And then I'm going to do this, and we're going to say sports car, and then sports car dot range. Notice how I just did like tab complete on all that because the IntelliSense comes up, it does the thing, and you've written these nice little fields. So literally, if you had object calling function that calls object that calls function, you can be like do ta-da, 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 ta-da. Like I can keep going all day long on that. I don't even know what just happened, but if you were fast enough, you could make magic happen real quick with coding. So anyway, that is basically it. So let's go over to our terminal here. I think we found out we don't need Java C. Java will actually take care of the whole thing. So I think I found that as a happy accident here. Add method to vehicle. Sounds good. Let's see what happens. Okay, minivan has 7. Vehicles a range of 336. Sports car has 2. Range of 168. That's about what I would expect, right? Because 14 times 12 is 124. Or sorry, 144 plus 28. So 164. 170. No, yeah. Okay, so 168. Yeah. And then 21 times 16 looks about that. Fine. I trust you. Cool. So anyway, that's adding a method to a class. We literally just added this method. All right. Cool, huh? All right. So now you know how to add something to an object that does something. All right. And now we're going to get into some more cool stuff. So again, just to clarify, this function does not take any parameters yet. We're going to go over that in a little bit here. It also returns nothing. So again, we're going to talk about that next. But basically, that's how you add a method to an object. And these methods can be very complex. Okay, so there's some ridiculous things that you can do with this. The Java language is very powerful. Cool. So now we're going to modify this guy. Okay. Let's see. Okay, but before we do that, I'm going to do an example over here in this Blackboard. Cool. So down here, I'm going to make a function called myMethod. All right. I'm going to declare an integer. All right. And I'm going to just do I equals 0. Put the spaces in there because I'm a conscientious coder. Then we're going to do as a test, we're going to loop 10 times, right? And we are going to exit if we are equal to 5, so we're only going to do this 5 times, right? And we're going to return. So that's the lesson here, is how to return from a method. And you've already kind of seen stuff like this with breaks. It's the same concept as a break, except it's actually exiting the entire method, right? A break exits the loop. So if I put a break here, it would actually end up here, right here. It'd be doing some stuff. But because we're doing a return, it's actually going to jump to here, and that's done, right? So that's important, very important distinction here. Okay. So basically, we can call this method up here. All right. Let's compile the Blackboard and run it. And no, I'm going to do this. Okay, sorry. If a static method calls another method, it has to be static as well. Ignore this for now. Pretend I didn't do that. We're not going to talk about this. Just pretend that I didn't even use the word static and I was just calling a method. Okay, we're going to go into examples that will work for you. So, but anyway, as you can see, return returns out of that method. Okay. In fact, you know what? I'll put a note here. So ignore that for now. Come back to it. Okay? Okay. All right. So let's do this. Let's add a return method to the vehicle. So here's what I'm going to do. Actually, let me go ahead and put a comment here, so you know what that does. And then I'm going to copy this guy. I'm going to go over here, and we're going to put a note. Add a method that returns a value to the vehicle class. Okay. I'm going to go down here. Okay. Now, this right here. I'm going to change this method. Okay. And I'm going to literally return the range this time. There. Now, I have now said there, that is the type of data that I'm returning from this method. All right. And so what I'm going to do now is, well, you probably already figured it out, but this is the range. So what can I do here? There's a couple different ways you might approach this. You might say, well, I'm going to make an integer called range, and I'm going to do that. And that is correct, because then you can go return range. But you can actually just do that, right? You can return the product of those two values. Okay. So what I'm going to do here is I'm going to do commented out block and say, no, this is more code. And I'm going to do an int, and I'm going to say range equals, actually I'm going to do that, and then I'm going to do return range, okay? So let's do that instead. Cool. So now we have a method in the vehicle class that calculates the range and returns it for us. So the calculation for range can be retrieved and used in any way whatsoever outside of the vehicle class. We didn't have to do the calculation. We just asked the vehicle, what is your range? We hid the formula. This formula could be some complex calculus equation. It could be some complex chemical formula, right? It could be some like voltage versus resistance reading on a circuit board. You could be doing something complex in here, and this method would do everything for you, provided it had all the right data going in and the right data going out. But we've shown you already that you can make a method that doesn't do any calculations and literally just prints stuff to the screen. But now we're showing you how to get data out of the method. Okay, so one step at a time, right? Okay, cool. So once again, we're going to grab all this, okay, because we're going to reuse most of this. Seeing a pattern here? So the difference here, okay, is we're going to need to store two ranges. So that's where I was getting ahead of myself. We're going to need range 1 and range 2, okay? And what we're going to do is we're going to comment these guys out here, okay? And let's forget about that for now. So what we want to do now is get the ranges, okay? And we're going to say range 1 equals the minivan dot range, right? And we're going to do range 2 equals the minivan dot range. Perfect, right? And so what that does, it calls the function range, calculates the range internally, hidden from view, whether it's hidden from yourself or hidden from the other guy, okay? You're getting data out of the system and you're saying, okay, cool, I got the range. Now what do I do with it? Well, now I can print the screen. So now we do this like we did before, except now we just yeah, that's exactly what I wanted. Okay, so copy that, do it again. We want range 2, we want the sports car, and we want to change this to read sports car. And we want to get rid of all this. Right? Okay, so now we are getting the range out and we're using that in our print statement. Okay? Which is a better use of our code, because you're not really going to be wanting to tell objects to print their contents. That's more of like a debug thing. In production code, you're going to be wanting to get the actual value out so that you can use it for some calculation elsewhere. Like maybe you want to get all the ranges of all your cars, and you also want to do a cross-reference with all the customers who purchased your cars and find out, okay, how far have they gotten out of ranges on their cars versus what does it say that the cars actually have as a range. And then you can start to do some data analysis on that and find patterns. So, add return method. So we're going to go here. Ta-da! Minivan can carry 7 with a range of 336, blah, blah, blah. Good. Although, I want to do print line. Let's make that pretty, right? We can do better, so let's do better. Good. Sounds good. Cool. All right, so that is returning a value, okay? Just to be clear, we are not talking about returning objects. We're talking about returning simple values. We will get into complex return objects later. That's not for now. Baby steps. I'm going to throw all the complexity at you later, and you're going to just get it because you're following along and you kind of see how all this stuff glues together. Once you understand this trivial, tiny stuff, the rest of it is really cool. But raise your hand out there if you're really enjoying seeing all this complexity arise out of nothing. Cool. So, using parameters. All right. How we do that? All right, so I'm going to go over here. Let's see where. Trying to think here. Right, okay. This is where I'm going to be. All right. So, okay, I'm going to make a class that checks number even. Okay? And it's going to have one method, and it's going to return true if x is even. Super simple. Now remember, the modulus operator can be used because we can say if the number modded by 2 is 0, aka it doesn't have a remainder of 1, it must be even. Okay, so this is going to be really easy. So we're going to do boolean as the return value, right? And then we're going to say is even as the function name, create our function. We're going to make our body. Now this is where it's different. Okay, we need a parameter. Okay, so how do we do that? Well, we want to pass in the type right? Now if we go over here to our Blackboard, we didn't define that. So I'm going to say an additional note. A parameter list is a comma delimited list of type value pairs. And then I'm going to give you an example. Example would be int count string name float speed. Cool. And you would wrap that in parentheses, right? So following that logic, we can come over here, or actually it's going to be over here, and we're going to say, well, I want to pass in a number. Because I want to know, is this number even? So it's an int, and it doesn't matter what it's called. I could call it chicken, for all I care. Don't do that. You're an asshole. But you could. I worked with a developer once that named something after it transformed data, and he called it Optimus Prime. And yeah, nobody knew what the hell his code did. So we're going to call it number. It's exactly what the hell it is. And we're going to say if, right? And then we're going to put, remember, I'm going to do this in parentheses because I want to say if x mod 2 equals 0, return true. Otherwise, return false, right? Now, you could have done this in an else, right? You could have done else return true or return false, but you don't need to, because as soon as this fails, it exits out of the if check, and you can just write that, okay? So that's from our if check lesson. So now we have a class called check number is even. Actually, we're just going to call it check number because maybe we want to put one in here that says is odd. Maybe we want to do that. We don't want to lock ourselves into a class that does one thing, right? So we're just going to call it check number. Maybe you want to check if the number is divisible by 5 and 3. Is a factor, like has factors 5 and 3, right? So be sure to name things in a generic way so that you don't make a one-door decision, they call it, right? One-door decision. So, all right, so I'm going to go over here. We're going to create a check number, and we're going to call it checker. And we're going to say new check number. Cool. And now, we can literally do this. If checker.isEven 10, then we can do system.out.println, right? 10 is even. And I'll show you why I did it this way, because I'm going to do this. I'm going to do that, and that. Now, based off of what I know about the code that we just wrote, we should see 10 is even and 8 is even, because this will fail, right? So let's run the parameter demo. We get an error because I'm an idiot. All right, let's run that again. Another one. Come on, guys. What's wrong with me? Because it's number, not x. All right, there you go. 10 is even, 8 is even. Sweet. So that's basically creating a method on a class that returns a value that's useful and takes in a value to do something with. So now you know how to put inputs in and get outputs out, right? All right. Cool. Let's go over to this demo. Actually, let me notate this. What does this one do? So, this is a simple example that uses a parameter. All right. Cool. What are we going to do here? Well, So we are going to find out if two numbers are factors of each other. Okay? It's very similar to what we just did. Very similar. Okay? So, what the hell? There we go. Cool. So we're going to make a class, and it's going to be called factor. Okay? And we are going to say, okay, we want is factor, so okay, I'm going to need a boolean, and then I'm going to say is factor is the name of my method, and I want to do it for two numbers, so obviously I need int number A and int B. Cool. Now I'm not going to get into algorithms in this class. I'm going to start skipping over algorithms in terms of mathematical operations and things like that, because that's not what I'm teaching you. I'm teaching you how to code. We could definitely go into an algorithms course later down the road. It's beneficial. But I think getting you up in coding as fast as possible so that you can start making things is more important. The better you know how to code, the better you'll be at making algorithms. A lot of people get thrown into making algorithms and they write shit code. Okay? Master the craft first, which is learning the language and writing beautiful code and following how others do that, and then you can start going down learning complex algorithms. Why do you want to learn algorithms someday? Maybe you don't, but if you do, algorithms is how you recognize patterns in the world, figure out a way to build that into software, and then you patent it. Yeah, that's where the money is. So, algorithms are your friend. Take an algorithms course at some point. Maybe I'll teach it, maybe I won't. We'll see. I want to get you guys up and running and building some really cool stuff, okay? So, how do we get the factor? Well, we're going to do something similar to what we did before, right? We're going to say if A is if A mod B equals 0, and there's no remainder, then they're factors of each other, because they evenly divide into one another, okay? Right. Okay, cool. So then that's going to return true. And then otherwise we return false, right? Cool. And then up here, so it literally looks the same as the last one, right? Literally looks the same. Because the check for whether you're even or not is the same as actually whether you are a factor of another number. So we're make another class called factor. And we're going to call it checker again. This is like literally the same code, but it does something different because the verbiage is different. And you might add other methods in here that have to do with factors. In fact, what you could do is you could literally have access to the check number inside here, and you could make an a check number class object in here and call is even. You could do that, but that's not, we're not, better to call methods by the name of what they mean, because what if you change what this means? Not saying you would. This is a very simple example. Okay, cool. So we're going to say if checker is factor, let's see, we're going to do 20 and 2. Yeah. And we're going to, whoops, go ahead and print out 2 is a factor. Okay. Then we're going to grab this again, copy that, and we're going to say this time we're going to check to see if 3 is, and then we're going to say this. Now, we know that 20 modded by 2 is 0, so this is going to say 2 is a factor. 20 modded by 3 is 2, so we're not going to see this. So we're only going to see 2 as a factor, right? So let's run that again. Oh, pint line. That ain't right. Okay, 2's a factor. Sweet. Okay. Now let's go back to the vehicle and let's do some fun stuff over there. So, what am I going to do? I'm going to grab this, the whole vehicle class. And what am I going to do this time? Well, the purpose of this is, let's write that out first. So we're going to add a parameterized method that computes the fuel required for a given distance. Cool. All right. So we're going to keep range. This time I'm going to go ahead and remove all the comments. We've got our range function right here. And we're going to document it. Okay? Then we're going to write another one. We're going to say this one, compute fuel needed for a given distance. Cool. Now, how's that going to work out? So, if you remember back from all of your old physics or science classes, you want to get let's do this. And I'm only doing this temporarily. I'm gonna erase this soon. But we have miles, and remember how when we had that's a fraction, and that would be over 1, right? And then you also have another value over here, and it's miles per gallon. And what we want to do is we know that these relate. So if we were to multiply these together, oops, I'm taking you guys back to math class. To do this together, you would get something like this. You get miles squared, right? Because miles times miles is miles squared, and then 1 times gallon is gallon. Well, that doesn't help us because we need to get the fuel needed, right? We need gallons. We need to get rid of miles. Okay, now we can't end up with miles squared. Well, remember the rules of multiplication is that you are able to cancel out terms like this, the units, right? So what do we actually want to do here? Well, if you divide by this fraction, then you're actually multiplying by the inverse of it. So what I can do here, and I'll show you this. So if I do miles divided by miles per gallon, right? Then let's refine my equation, because if I change this to a divide, then it means I have to flip this, right? That's exactly what I want, because now I have gallon divided by 1. Now I'm taking you to like a math class. You don't really need this, but I'm just showing you how I could reverse engineer an equation just by looking at all the units and trying to get to what I need. And so I can cross-reference these. I can cancel these out, and I get gallons over 1. Cool. That's exactly what I want. So miles divided by miles per gallon. So if you want to not computer the fuel, you want to compute the fuel. So we're going to assume that your miles is going to be passed in, because we don't have that here. So we know that a given distance is a number of miles. And when we divide that by the miles per gallon, we also might get a decimal type number, right? We may get a decimal because it could be, if it's an integer divided by an integer, right? If you know you've traveled 53 miles and your miles per gallon is 10, you're going to actually end up with like 53, it's like 5.3. But actually, you're not going to get that because if you return an integer, you're going to get 5, and you're going to lose data. So we're going to return a double. Okay? And then we're going to call this fuel needed. And then the parameter is going to be miles. And then we're literally going to do return miles divided by miles per gallon. And this is why I said use this, because I know miles is not part of this class, but miles per gallon is. Now also, keep this in mind. This is not going to return a double. Why? Well, I'll show you. This is add parameter method to vehicle. It totally did. Why did that compile? Because it will compile. That sucks. This is a bug. You want to do this. You want to cast it to a double. So you can preserve the fact that you want the decimal representation of these two values, not the integer division. Careful. Cool. So I can get rid of this, because this is not a math lesson. I'm going to keep this nice and concise. Cool. So we've just designed our vehicle. We've added a fuel needed function. So now let's go back. Here. And grab all this. Okay. Cool. That's a lot of code. But what I want to do is I want to store another value here for gallons. And let's see. You know what? I am not going to print the range this time. Last time I print the range, but we're not going to do that. We're going to save ourselves the code. So we know we're going to need to capture the gallons as a return value, and then we know that we're going to check a static distance of some arbitrary value. So we're going to go with 200. No, we're going to make it some like odd numbers. So we'll go like 252. Cool. Okay, so we set up our cars the same way we did before. This time, before we print, we're going to say gallons equals minivan dot fuel needed, and we're going to pass in that distance. We're going to actually call it distance because I hate shortcuts like that. All right, and then we're going to copy this, get out of here, and we're going to go. Yeah, we'll just go ahead and redo the whole string. To go a particular distance, miles, minivan needs gallons, gallons of fuel. Okay. Now let's do that for the sports car. Now, we're overwriting gallons, but that's okay because we already used it where we needed it, so we can use that same variable a second time. Okay, let's grab our sports car, and let's just plop that in there. Okay, I think that's fine. So as you can see, I reused all that vehicle code, and I used the setup information and everything. I even used the allocation of the vehicles as well, and it saved me a lot of time, right? Saved us a lot of time. So, what the hell? Oh, equals. Ta-da. Awesome. That's a suspicious number. That's very suspicious. To go 252 miles. Well, let's clarify this. So our calculation is what? Miles divided by miles per gallon. So if I go 252 miles and I divide that by 21, okay. That's probably was a bad number to use. Let's change that. I want to run the number again. We're going to divide by 12 this time and get 21. Yeah, let's use a different number. Let's use 243. I feel like that's gonna be an interesting number, right? Yeah, that's way more interesting. Now, of course, we didn't round it, right? We got 11.57 and some garbage at the end. We don't care, right? But for the purposes of the demonstration, we see now that we have preserved the precision. So that's good, because we can supply the precision and we can let the data analysis decide how precise they need that number for their calculations, because maybe they don't need it to be ridiculously precise. So, okay, that is it. That's it. So next week, let's see. I'll give you a sneak peek. Let's see. What are we gonna go and do next time? Or Thursday, I should say. What am I gonna go over? Okay, so we're going to learn about constructors. We're going to play around with that. I'm going to teach you a little bit about what this new keyword means when you create an object, garbage collection, about a particular method called finalize that all objects in Java get. And then I'm actually going to take us back around and talk about this keyword that I touched on briefly here. So we're going to go over all those things in the next lesson. We're going to rip through those, and that's it for chapter 4. So after that, I might take a quick break to collect my thoughts before moving on to the next lessons, because there's a lot of chapters that we have to go over. But chapter 4, out of how many chapters are in this? We're going to go over how many chapters? Oh, there's like 17 chapters, but we're not going to do all these chapters. So we're like probably almost a third done with the book. Maybe 25%. And that's actually really good. So you guys are slamming through this. Sooner or later, we're going to start doing some pretty cool projects. Yeah. Anyway, I'll see you guys soon. All right. Later.